everybody. My name is Andrew Barnard. I'm an assistant professor in Mechanical Engineering, Engineering Mechanics department. I've been there for 2.5 years now. I'm an alumni. I have a BS and MS from here, and my PhD's from Penn State in acoustics. That's my field of expertise, acoustics and noise control. I also do signal processing and data acquisition. And you'll see a list here of some of the things I do: carbon nanotube thin film loudspeakers, which you'll see on the next slide. Very different from that is underwater acoustics. I do structural acoustics and noise control. Crowd noise, another very different aspect. I've done a lot of large crowd noise assessments at 110,000 seat stadiums. And then I'm a LabVIEW certified developer. I do a lot of LabVIEW work with dynamic data acquisition. Okay, well that didn't work right off the bat. So I was supposed to be pushing the button here, but, well, okay. I'm just going to talk. So, in a world where our electronic devices are getting smaller and smaller, we want our electronic devices to make noise. So we need something other than a traditional moving coil loudspeaker. So up there you see a flexible cell phone. How do you put a loudspeaker in a flexible cell phone? Not easily. What I have and what I'm working on is something called a carbon nanotube thin film loudspeaker. So what you see here are carbon nanotube aligned thin films being rolled over electrodes. And it ends up in a speaker that looks something like this. That speaker is about 5 carbon atoms thick. And the reason that this is called a hot topic is because it makes sound by oscillating its surface temperature. So it's a solid state device that doesn't move. We don't need magnets. It makes sound with heat, which is kind of interesting. So where can we use that other than electronics? One application area I'm looking at is active noise control in muffler systems. Another one is embedding that material in complicated systems, things like helicopter health monitoring and blade tip de-icing. And that's all. So,